Have you ever wondered if we could turn back the hands of time, or perhaps slow it down to a crawl? This question has been the subject of countless science fiction novels, movies, and television shows. Characters in these stories often wield the power of time travel, using it to right wrongs, prevent catastrophes, or even just to get a sneak peek at the future. But what if this concept, so often relegated to the realm of fiction, has a basis in reality? What if time isn't just a relentless march forward, but rather a dimension that can be manipulated, stretched, and maybe even reversed? This is where the science of time comes into play. From the ancient sundials to the ultra-precise atomic clocks of today, humans have always been fascinated by the concept of time. We have sought to measure it, to understand it, and perhaps most intriguingly, to control it. In everyday life, we experience time as a constant, unchangeable force. Every second ticks by at the same steady pace, every minute and hour slipping away with unwavering regularity. But what if I told you that according to the laws of physics, time doesn't have to work this way? Physicists have proposed that time is not just a simple forward progression. Instead, it's a dimension, much like the three dimensions of space we're familiar with. This idea suggests that time can be manipulated, just like we can move up and down, left and right, forward and backward in space. Of course, this is all theoretical. We don't have a time machine to test these ideas. But we do have some intriguing scientific theories and a wealth of mathematical evidence that suggests the possibility of time manipulation isn't as far-fetched as it might seem. While time travel remains a captivating mystery, science does offer us a glimpse into the possibility of slowing down time. So, buckle up and let's dive into the mind-bending world of time, where seconds can stretch into hours and the past might just be a destination. To understand how we might slow down time, we need to delve into Albert Einstein's theory of relativity. This revolutionary theory, presented by Einstein in the early 20th century, fundamentally reshaped our understanding of the universe and the fabric of time itself. First, let's break down the basics of the theory of relativity. It's composed of two parts: special relativity and general relativity. Special relativity tells us that the laws of physics are the same for all non-accelerating observers. And this is the mind-boggling part. It says that the speed of light within a vacuum is the same, no matter the speed at which an observer travels. General relativity, on the other hand, takes it a notch further. It proposes that massive objects cause a distortion in space-time, which is felt as gravity. Imagine a bowling ball placed on a trampoline, causing a dip in the fabric. This is how massive objects like stars and planets distort space-time around them. Now let's introduce the concept of time dilation, a direct consequence of the theory of relativity. Time dilation describes why two clocks, one stationary and one in motion, will not measure time the same way. To the observer in motion, time seems to pass normally. However, to a stationary observer, the clock in motion appears to tick slower. Let's conceptualize this with an analogy. Imagine you're on a train, reading a book. To you, the book's pages turn at a normal pace. But to someone watching you from the platform, your actions seem to be in slow motion. That's time dilation in action. This phenomenon isn't just theoretical. It has been tested and proven with precise atomic clocks on board satellites and airplanes, which indeed tick slower than their counterparts on Earth. So, time dilation, a concept birthed from Einstein's theory, suggests that time can indeed be slowed down. Stay tuned as we explore the practicality of this concept and its implications in the next scenes. But what does time dilation look like in real life? Is it just a theory, or is there any practical evidence? Well, let's take a look at some real-world scenarios where time dilation isn't just a theoretical concept, but an observable, measurable phenomenon. One of the most fascinating examples of time dilation in practice involves our Global Positioning System, or GPS. The satellites orbiting Earth for GPS are moving at high speeds relative to us on the ground. According to Einstein's theory of relativity, time should pass more slowly for these fast-moving satellites. And indeed, it does. If we didn't account for this time dilation, GPS systems would quickly become inaccurate, leading to errors of several kilometers. This is no minor discrepancy. It's a daily reminder of the practical reality of time dilation. But the evidence doesn't stop there. Another compelling example comes from an experiment conducted in the 1970s involving atomic clocks on airplanes. Atomic clocks are incredibly precise timekeeping devices, allowing us to measure time dilation effects very accurately. In this experiment, one atomic clock stayed on the ground, while another took a trip around the world on a commercial airliner. When the flying clock returned, it had recorded less time than the one on the ground. This was exactly in line with Einstein's predictions about time dilation effects due to both relative velocity and gravity. These examples show that time dilation isn't just a theoretical concept. It's a real-world phenomenon with practical implications, from ensuring the precision of our GPS systems to confirming the predictions of one of the most groundbreaking theories in physics. We can't ignore time dilation. Instead, we have to work with it, adjust for it, and continue to explore its fascinating implications. So, as we ponder the mysteries of time, we find that time dilation isn't just confined to the realm of science fiction or theoretical physics. It's a part of our daily lives, affecting the technology we rely on and confirming our understanding of the fundamental laws of the universe. These examples show that time dilation isn't just a theoretical concept, but a phenomenon that we can observe and measure. If time dilation is real, what does this mean for us and our understanding of the universe? This question is more than just a philosophical musing. It's a challenge to our traditional understanding of time and space, and it's a door to a whole new realm of possibilities. What we have always believed about time, that it flows at a constant rate for everyone, everywhere, gets a serious twist through the lens of time dilation. It tells us that time isn't a universal constant after all. It's flexible, it's relative, it's a fabric that can stretch and bend. This is a radical departure from our everyday experience, and it's a concept that can be a bit unsettling, but it's also incredibly exciting. Imagine a world with technology that could harness the principles of time dilation, devices that could slow down time for us, allowing us to experience minutes while years pass by in the outside world. It sounds like science fiction, but the science of time dilation tells us it's theoretically possible. And then there's the impact on space travel. The vast distances of space are one of the biggest challenges to exploring the universe. But with time dilation, a round trip to even the most distant star could be completed in a human lifetime. The astronaut would age only a few years, while centuries would pass on Earth. It's a mind-boggling concept, but it could open up the universe to human exploration in a way we've never imagined. But as with any scientific breakthrough, there are also ethical considerations. If we could manipulate time, who gets to decide when and how it's used? The implications are profound and far-reaching. So yes, time dilation challenges our traditional understanding of time and space. It's a concept that's difficult to wrap our heads around, but it also opens up a world of possibilities. It's a tantalizing hint that the universe may be much stranger and much more wonderful than we ever imagined. Time dilation opens up a whole new realm of possibilities and questions about the nature of our universe. So, does time dilation mean we could travel back in time? This question has sparked the imagination of scientists, philosophers, and science fiction enthusiasts alike for generations. In theory, time dilation does open up the tantalizing possibility of time travel. But the practical implementation presents us with a multitude of challenges and paradoxes that are yet to be fully understood. Time dilation, as we've already discussed, is a proven phenomenon. We've seen it in action in GPS satellites, and with astronauts returning from space, a fraction of a second younger than their counterparts on Earth. However, using this concept to travel back in time is a whole different ballgame. Theoretically, if we could travel faster than light, we could go back in time. But according to Einstein's theory of relativity, this is impossible. As we approach the speed of light, our mass would become infinite, requiring infinite energy to move, which is, well, impossible. So in that respect, time travel to the past remains a concept of fiction. Then there are the paradoxes. The most famous of these is the grandfather paradox. Imagine if you could travel back in time and accidentally cause the death of your grandfather before your parent was born. This would mean you were never born, but then how could you have gone back in time in the first place? It's a mind-bending conundrum that challenges our understanding of causality and the nature of the universe. There's also the issue of the vast energy requirements and the potential for catastrophic consequences. Distorting space-time to create a wormhole or a time machine could result in everything from black holes to ripping the fabric of reality itself. While time travel remains a tantalizing concept, it's clear that our journey to understanding time and its mysteries is far from over. Despite these challenges, the pursuit of understanding time travel pushes the boundaries of our understanding of the universe, driving us to question, explore, and innovate. Who knows what discoveries lie ahead?